Welcome back to my today's session on problem discussion, especially on the electrostatics. This is from the Unit 1, and today we are going to discuss some important problems on electromagnetic field. So first we will discuss what is the main course outcome. Students will able to make use of the Coulomb's law for obtaining the force and electric field intensity due to line, surface and volume charge distribution. Understand or recognize the basic nomenclatures of point charge. Apply the Gauss law for obtaining the electric field intensity, flux density for uniform and non-uniform regions. So first we will discuss about the Coulomb's law. What is the Coulomb's law told? Coulomb's law told that, this is just a quick recap. Coulomb's law told that if there is two-point charge, the force between them, the force working between them can, if one charge is Q1, another charge is Q2, force is directly proportional to Q1 and Q2, and force is inversely proportional to 1 by R square. And if we combine these two, we will get force is equal to Q1, Q2 by R square, and force is equal to 1 by 4 pi epsilon naught Q1, Q2 by R square. If we think about the direction is AR. What is the AR? AR is if the distance is R, it is along the distance. So what is AR? AR is the unit vector which can be written as R hat by mod of R hat. Now we will discuss about, so Fi2 is equal to Q1, Q2, 4 pi epsilon naught R12, A12. 12 means Q1 and Q2. What is electric field intensity? Electric field intensity means the force needs to bring one unit charge from one place to another place is known as the electric field intensity. So what is electric field intensity? To bring the force needed to bring one unit charge from infinity to one place. We can write electric field intensity E is equal to force by Q. Coulomb's force by Q. Then we will discuss about the Gauss law. What is the Gauss law? According to the Gauss law, electric flux passing through any closed surface is equal to the total charge enclosed by the surface. So what is Gauss law? Gauss law tells the electric flux passing through any closed path. The electric path passing through any closed surface is equal to the charge enclosed by the surface. We can write psi is equal to closed path integration of ds into ds. What is ds? ds is equal to the flux density. What is this ds? ds is equal to the surface area. Surface area. So charge is equal to the charge enclosed Q. If we think there is a charge Q, there are the n number of charge is equal to Q, then from the Gauss law we can write psi is equal to Q. Psi is equal to electric lines of force. Psi is equal to electric lines of force. So based on this, we will discuss our first problem. A charge of 0.12 microcoulomb, micro means 10 to the power minus 12, is located in the vacuum at a point. Vacuum means in the free space. Vacuum means free space. Vacuum means nothing but the free space. At P2, P2 is 1 point, and what is the value of the P2? Minus 0.03, 0.01, 0.04 meter. Find the force on Q2 due to Q1 Q1 is equal to 100 microcoulomb at P1. What is the position of P1? 0.03, 0.08 minus 0.02. So if we are thinking the two things, this is our x-axis, this is our y-axis, and this is our z-axis, and we have 2 points. First one is the Q1. Q1 is in this side, negative side, because z is negative. So it is 0.03, 0.08 minus 0.02. What is P2? P2 is on the P2 is equal to this side, and what is P2? Q2 is equal to minus 0.03, 0.01, 0.04. So first we have to calculate the distance between Q1. We have to calculate the force on Q2 due to Q1. Force on Q2 due to Q1. So the direction of R12 will be 1 is the starting point and 2 is the end point. So what is the R12 equation? R12 is equal to end point minus starting point. We know from the previous discussion that the line distance is equal to always end point minus starting point. What is the end point? End point is minus 0.03 ax minus what is the point vector of Q1? 0.03 ax plus 0.08 ay minus 0.02 az. What is the point of Q2? Minus 0.03 ax minus 0.01 ay, 0.04 az minus 0.03 ax plus 0.01 ay plus 0.04 az. So end point minus starting point minus end point minus starting point, and if we write the value, it is coming minus 0.06 ax minus 0.07 ay plus 0.06 az. So what is the length of the line? How to get the length? The length can be calculated as ax square plus ay square plus az square. The coefficient of x square plus coefficient of y square plus coefficient of z square. So it will come like square root of 0.06 square plus 0.07 square plus 0.06 square. So if we solve this, we will get R12 is equal to 0.12 meter. So the distance between the 2 points Q1 and Q2 is equal to 0.11 meter. This is the first part of the question. Now next we have to calculate the direction. So how to calculate the unit vector? We know unit vector A12 is equal to R12 vector by mod of R12 vector. So what is the R12 vector? Minus 0.06 ax minus 0.07 ay plus 0.06 az divided by the magnitude. Magnitude is the 0.11. So if we solve this, we will get A12 is equal to 0.545 ax minus 0.336 ay plus 545 az. So we got the value of A12. What is then F12? F12 formula is Q1 Q2 by 4 pi epsilon R12 square in the direction of A12. So what is the value of the Q1 Q2? Q1 is given as 0.12 microcoulomb, 0.121 microcoulomb, and Q1 is given as the 100 microcoulomb by R square. R square means the distance square is 0.11 square into 1 by 4 pi epsilon 0 value is 9 into 10 to the power 9. And the direction is A12. So if we solve this value, we will get the equation of the F12 value is 9, A12 and the force is in Newton. This is the SI unit. So the unit will be Newton. So what are the steps? First we have to, what are the steps? If we want to write the steps of this problem, what are the steps? So step 1. What is step 1? Step 1 will tell, first we have to calculate the position vector, calculate the position vector of the 2 points. Position vector of 2 points. What is step 2? Step 2 is we have to calculate the distance between 2 points. And what is the formula of calculating the 2 points? End point minus starting point. End point minus starting point. And what is the step 3 then? Step 3. What is the step 3? We have to calculate the unit vector. And what is unit vector? R12 by mod of R12. We write by A12 cap. So we can calculate the unit vector. And what is step 4? Step 4 is use Coulomb's law. So if we follow this tree, we can calculate the total the force on the charge. So there is another problem we will discuss. 4 equal point charge. So we have now 4 equal point charge. 20 microcoulomb are in free space P1 000, P2 400, P3 440 and P4 040 respectively. Find the net force on Q5 200 microcoulomb at 000. So again we are drawing the X, Y, Z. So what are the points? First one is the P1. The red one is showing the P1. What is the value of the P1? 0, 0, 0. What is the value of P2? 400. So it is on the x-axis only. 4, 0, 0. This is P2. What is P3? P3 is 4, 4, 0. Means it has the x and y. So somewhere in this place. So we can write like P3 4, 4, 0. And P4 is again on the y-axis. 0, 4, 0. So we have this 4 point P1, P2, P3 and P4. We have to calculate the force on another Q5. What is the value of Q5? 0, 0, 0, 3. Here we have to use, so for solving this problem, we have to use the superposition theorem. Superposition theorem. What does the superposition theorem tells in the case of the EMF? We have to calculate each point. This is the end point. So we have to calculate the each point. We have to calculate the 4 forces. The forces are F15, F25, F35 and F45. So we have to calculate the individual force, and total force is the summation of M15 plus F25 plus 35 plus 45. So like this we can calculate the force. So first the R1P or 15 we can calculate what is the distance, what is the unit vector of this. This is the 0. What is the unit vector of this? 0. What is the unit vector of P5? The P5 position vector is only 3a z. So what is the distance? The distance is 3az and 3 meter. So what is the unit vector? Unit vector is only az. So r1p unit vector is only az. Next move to the r25 or r2p. So what is the position vector of the second one? The second one position vector is, second one is the p2 for ax only, ay and az components are 0. So for end, this is the end point minus starting point, 3az minus 4ax. 3az end point minus 4ax. So what is the magnitude? Magnitude is 3 square plus 4 square is equal to 5. Magnitude is the 5 meter. What is the unit vector? Minus 4 by 5 plus 3 by 5. So we are getting the unit vector here, minus 0.8 ax plus 0.8 az. 0.8 ax plus 0.6 az. Next we will calculate the r3p. What is the vector of the r3p? R3p position vector is 4ax plus 4ay. So what will be the equation? 4ax end point minus starting point. So minus 4ax minus 4ay plus 3az. My end point, starting point 3az minus 4ax minus 4ay. So what is the value? The value is 6.4 meter. 6.4 meter. So what is the unit vector? Unit vector is square root of end point minus starting point. So if we put the value of end point and starting point, we will get the r3p. What is r4p? R4p is equal to minus 4ay plus 3az. So minus 4ay plus 3az means minus 0.8 ax plus 0.6 az. So if we put all the value, then we will calculate what is the total force then. Total force is equal to QP, means the point in the fifth, by Q1 by R12 square. So if we take it common, QP 4 pi 10 to the power minus 9 36 pi. Then we are taking the value 20 by R1p square, 20 into 10 to the power minus 6 R2 square. Like this we can write the 4 equation, and ultimately we will get the value of minus 1.7 ax minus 1.7 ay minus 1.7 az Newton. So this is the unit 3. We have to, what is this main thing? We will use the, so what are the step 1? Step 1 is use the Coulomb's law for each pair of charge. Each pair of charge. What is the step 2? Step 2 is we use the superposition theorem. Use the superposition theorem. So this is the discussion of the problem 2. Now we are moving to the problem 3. Calculate the electric field E at a point. We are calculating the electric field E at a point minus 0.2, 02.3 in the free space caused by a charge 5 nanocoulomb at this point. So how to calculate again? So again we are drawing this value x, y and z. What is the value of the P? Minus 0.2, 0, minus 2.3. So somewhere in this position, minus 0.2, 0, 2.3. This is our P point. What we have to calculate the at the N1. What is the N1? 0.2, 0.1 minus 2.5. So what is the position vector of P? position vector of P is 0.2 AX plus 0 AY plus 2.3 AZ. What is the position vector of N? N position vector is 0.2 AX plus 0.1 AY plus 0.1 AY minus 2.5 AZ. Now we have to calculate the field at P due to N. So direction is from N to P. End point is P and starting point is N. So what is the equation of the R? P N. End point is P is equal to end point minus starting point. What is the end point? End point is, we know, minus 0.2x plus 0 AY plus 2.3 AZ minus 0.2 AX minus 0.1 AY plus 2.5 AZ. So if we solve it, we will get 0.4 AX minus 0.2 AY plus 4.8 AZ. So what is its magnitude? The magnitude of this line is, what is the magnitude? Magnitude is 0.04 square plus 0.2 square plus 4.8 square. So these are the similar to the Coulomb's law. Then how to calculate the intensity? The intensity E is equal to Q by 4 pi epsilon R square AR. So what is the value of Q? Q value is given as the 5 nanocoulomb. Nano means 10 to the power minus 9 divided by 4.3.14 into 8.854 into 10 to the power minus 12. R square means here RPN square, magnitude of RPN square. What is AR? RPN by mod of RPN. So if we solve it, we will get the value of E. And what is the unit of P? Unit of E is Newton per Coulomb, or we can write ampere per meter. So this is the problem 3. Problem 3 is similar to the problem 2. Here we are calculating the electric field at a point is minus 0.2. So what is the step 1? Again, if we want to write the step 1 and step 2, what is the step 1? Step 1 is, what is the step 1 to solve this problem? Calculate the position vector of P and N. What is the step 2? Step 2 is calculate the distance vector, and in this time we should know what is the end point and what is the starting point. For the step 3, what is the step 3? We should know the, what is the step 3? Step 3 is calculate the unit vector. And what is the step 4? Calculate the intensity. What is the formula of intensity? E is equal to Q by 4 pi epsilon R square AR. So these are the 4 steps to calculate the intensity. So we will move to the problem 4. Given a field vector is E and E value is given as 6 by x squared AX plus 6 by XAY plus 5AZ volt per meter. Calculate the potential difference VAB at point -721 and B is equal to 412. So we have to calculate the dV. What is the dV? We know dV is equal to minus E dot dl. So E is equal to minus integration of E dot dl. What is E? E is 6y by x square dx plus 6 by x dy plus 5z dz. And from B to A, VAB means B to A. So we can write 4 minus 7 minus 6y by x square dx plus again B to A 1 to 2 6 by x dy plus integration of 5 into dz. What is the value of the dz? 5 into z dz means 5. It is from 1 to 2. Sorry, 2 to 1. B to 1. If we on integrating these points, we will get the value minus 8.214 volts. If we integrate the total things, we will get the value minus 8.214 volt. Let's move to the problem 5. The potential in a given phase B is equal to 80 R to the power 0.6 volt. Assuming the free space condition, calculate the E. So what is E? E is equal to minus dV by dr. E is equal to grad V. What is the meaning of grad V? Minus dV by dr AR. So what is the 0.680 R to the power minus 06 AR? So it is coming 0.48 into 80, 48 R 0.4 AR V. So we got the first equation. Calculate the volume charge density at R is equal to 0.5. We have to calculate the volume charge density. So we can calculate the value of the E. So what is the value of D? D value is epsilon into E. As this is a free space, we can write 8.854 into 10 to the power minus 12 into minus 48 R to the power 0.4 AR into V. So what is rho V? Rho V is equal to grad dot D. We get it from the Maxwell's equation. From the Maxwell's equation, we know that the grad dot D is equal to rho V. What is the meaning of grad? D by dr into D. So D value we got here. If we solve this, we can get the value of the rho V. What is the total? If we get the rho V, this is the question number B, and what is the C? C is the what is the C? In the C, we will calculate the total charge lying within the surface R is equal to 0.6. So what is the total charge Q? Q is equal to rho V into V, volume. So rho V value we got. Rho V value we will get. What is the volume? Pi R cube. So rho V into pi R cube. If we put the value, we can get the total charge lying within the surface. So we are getting 4 pi R square, the charge from the equation, or we can use we know the value of the D. We can solve it like this also, that the total charge is D according to the D dot ds is equal to the total flux psi, and according to the Gauss law psi is equal to Q. D value we know, ds value 4 pi r square, so we can calculate the Q. Both we can use to solve the question number 5. So first step is, so if we go for the first step, E is equal to grad V is equal to minus dV by dr. If we put the value, we will get the minus 48 AR volt per meter. Next is the second question. D is equal to epsilon not E. So if we put the value, minus E value we got already, so we will get the value of D. What is rho B? Rho B is equal to grad dot D, and if we solve the equation, we will get the value of rho V. Again for the part C, we know the total charge. For the part C, we know the value of the D, and D dot ds is equal to psi from the Gauss law. So, and from the Gauss law psi is equal to Q, so we can solve the equation. So today we have discussed some 5 important problem on the electrostatic field. So this is my today's lecture today. So this is the today's lecture, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.